How can we model the electric field? Modeling electric fields. How can we picturize them? I have a positive charge here. It creates a field around it. We represent field using field lines. Okay, the field lines of positive charges point away from the positive charge. All the field lines are pointing away from the positive charge. So this is how the electric field of a positive charge would look like. Now what about a negative charge? A negative point charge. It's very similar, but the electric field lines would be pointing towards the charge. Now if you have a positive charge and a negative charge, the electric field lines would originate from the positive charge and it would end up on the negative charge. So this is the electric field for a positive and a negative charge. Now if we have two like charges, this is how we model electric field for two positive charges that are very close to each other. Now for two negative charges, it's the same except the direction of the field lines are towards the negative charge. Let's solve a problem now. The electric force between the two charges Q equals minus 3 microcoulomb and Q equals plus 2 microcoulomb is 7.3 times 10 to the power of minus 4 newtons, and the distance between them is 8.6 meters. If Q is placed at 5, 0, what is the electric field at the point 0, 0? We have two charges in this problem. A negative charge, minus 3 microcoulomb, placed on the y-axis. Another positive charge, plus 2 microcoulomb, placed at 5 meters on the x-axis. The distance between these two charges is 8.6 meters. And we need to find the electric field, the net electric field at the origin, at this point. Find the electric field at this point. That's the question. I'm going to find this distance first. It's a right triangle. This is 5 meters. This side is 5 meters. This is the hypotenuse. It is 8.6 meters. So this side will be square root of hypotenuse square minus 5 square, 7 meters. So the distance from the negative charge to the origin is 7 meters. Now let's solve this problem. So we have two charges. The total electric field at the origin E is due to charge number 1. Let's call this charge number 1. Let's call this charge number 2. Electric field due to charge number 1 plus electric field due to charge number 2. Let's find the electric field of charge Q at the origin, the magnitude of the electric field of the first charge is equal to, the equation is kq over r square, where k is 9 times 10 to the power of 9, q is the capital Q, which is 3 microcoulomb. Not going to take the negative sign now, we will consider the direction later. 3 times 10 to the power of minus 6 over this distance between charge Q and the origin is 7 meters, 7 square. 551 Newton per coulomb. Now let's find the electric field due to charge 2. Electric field created by charge 2, which is this small positive charge at the origin. The same equation, kq by r square, k is 9 times 10 to the power of 9. This time the charge is the second charge, which is 2 microcoulomb, so 2 times 10 to the power of minus 6 over a distance between charge q and the origin, which is 5. It's 5 square. The answer is 720 Newton per coulomb. What is the direction of these electric fields? This is a negative charge. For a negative charge, the electric field lines are coming towards the charge. The direction of the electric field line at the origin should be pointing towards this charge. So that's the direction of electric field due to charge number 1. This is charge number 1. And what about charge number 2? It's a positive charge. So for a positive charge, electric field line should be going away from the charge. So this is our charge. So the electric field line should be going away from it. So that's the direction of the electric field created by the second charge, E2. We have two vectors. So the net electric field can be written as E1 is 551, that's on positive y-axis, so y cap, and E2 is on negative x-axis, minus 720 x cap. Our resultant should be somewhere in between these two vectors. So that's our resultant. How do you find the magnitude of this vector? E equals square root of x square plus y square. So minus 720 the whole square plus 551 the whole square. That is 906.6 Newton per Coulomb. That is the magnitude of the electric field. To find the direction, let's find this angle theta. Theta equals tan inverse y component over x component, so Ey over Ex. If you do tan inverse, y component is 551 over x component is minus 720, you will get this angle.